Mechanism of action of beta-lactam antibiotic is inhibition of bacterial cell wall synthesis. Let's see how it happens. A gram-positive bacterial cell wall consists of plasma membrane made up of lipid bilayer and proteins. Outer to plasma membrane is peptidoglycan layer. Peptidoglycan is a polymer made of N-acetyl myramic acid alternating with N-acetyl glucosamine. In gram-positive bacteria, the peptidoglycan layer is very thick, consisting of many strands. The lipoic acid anchors the peptidoglycan layer to the lipid bilayer. Proteins called transpeptidase enzymes helps in cross-linking of the peptidoglycan strands, which is essential for the stability and rigidity of the bacterial cell wall. The transpeptidases are also called as penicillin-binding proteins. The beta-lactam antibiotics, which contains beta-lactam ring binds to the penicillin and binding proteins. Thus, cross-linking of the peptidoglycan strands is interfered. When susceptible bacteria divide in the presence of a beta-lactam antibiotic, cell wall deficient forms are produced. As the interior of the bacteria is hyperosmotic, the bacteria swell and burst. Thus, beta-lactams are bactericidal. Gram-negative bacterial cell wall also consists of plasma membrane, but the peptidoglycan layer is very thin. In addition to the plasma membrane, there is another outer layer of lipid bilayer. It contains porins and the lipopolysaccharides. Lipopolysaccharides are specific to gram-negative bacteria. It is also known as endotoxins, as gram-negative bacteria has outer membrane and a thin peptidoglycan layer with few cross-linkings. They are less susceptible to beta-lactam antibiotics. Let's see how the bacteria develop resistance to the beta-lactam antibiotics. First is the production of beta-lactamase enzymes. It opens up the beta-lactam ring in the antibiotic, so it cannot bind to the penicillin and binding proteins. Thus, the bacteria are resistant to beta-lactams. The second mechanism is to production of altered penicillin binding proteins. It has low affinity for beta-lactams, so there is less inhibition of penicillin and binding proteins. Thus, the bacteria are resistant to beta-lactams. But resistance via beta-lactamers can be overcome by combining the beta-lactams with beta-lactamase inhibitors. There are three beta-lactamer inhibitors available for clinical use. They are clavulandic acid, sulbactam, and tazobactam. Let's see the antimicrobial spectrum of beta-lactam antibiotics. Penicillin is a narrow-spectrum antibiotic. It is potent primarily against gram-positive organisms. It inhibits only a few gram-negative organisms. Extended spectrum penicillins like ampicillin and amoxicillin are active against all organisms sensitive to penicillin. In addition, it inhibits many gram-negative bacilli like Haemophilus influenzae, Helicobacter pylori, Escherichia coli, Salmonella, Shigella, and Proteus. Piperacillin is also an extended spectrum penicillin. It is an anti-pseudomonal penicillin. It also inhibits clavicillin and anaerobic organisms. Cephalosporins are chemically related to penicillins. The nucleus consists of a beta-lactam ring fused to a dihydrothiosin ring. Cephalosporins are chronologically divided into four generations. But most importantly, the division takes into consideration of antibacterial spectrum as well as potency. The first generation drugs are mostly active against gram-positive organisms. The second generation drugs are more active against gram-negative organisms, except Pseudomonas. The third generation drugs are also more active against gram-negative organisms. In addition, it is active against Pseudomonas. It should be observed that as the generation goes up, the gram-positive coverage decreases and the gram-negative coverage increases. The fourth generation drugs are beta-lactamase resistant and it is a potent anti-pseudomonal agent. Let's see about other beta-lactam antibiotics. Monobactams are beta-lactam antibiotics without the other ring. Hence it is called monobactam. Azthrionum has no gram-positive coverage. It is active against gram-negative aerobes like aminoglycosides and it is beta-lactamase resistant. Carbaphenams like imifenum and meropenem are extremely potent broad-spectrum beta-lactam antibiotics. It has gram-positive, gram-negative, and anaerobic coverage. It is resistant to most beta-lactamases, but not active against MRSA.